Ever wondered how AI models like ChatGPT or Qwen can suddenly sound so confident when discussing niche topics, like medical research or stock markets? The truth is, while these giant language models excel at general tasks, adapting them to specific fields is a real challenge. Today, we're diving into a breakthrough called Memory Decoder, a game changer that's making AI both smarter and faster. Let's start with the problem. Traditional methods for tailoring LLMs to domains like medicine or finance have major flaws. Domain Adaptive Pre-training, DAPT, forces models to relearn everything from scratch, like rebuilding a car's engine just to drive on a new road, expensive, risky, and inefficient. Then there's Retrieval Augmented Generation, RAG, which tries to cheat by pulling in external data during answers. But this slows things down, like using a GPS that takes forever to find your route. Enter Memory Decoder, a clever solution that's both fast and flexible. Imagine a tiny AI assistant pre-trained to mimic the memory of a huge database, but without the hassle of searching through it. This little decoder doesn't change the original model's settings. Instead, it acts like a bridge, injecting domain-specific knowledge on the fly. Here's how it works. During training, Memory Decoder learns to think like a non-parametric retriever, essentially, a system that stores information without training. But instead of needing a massive database, it compresses that knowledge into a small transformer model. When answering a question, it combines its own predictions with the original model's output, like a team working in harmony. The proof is in the numbers. In tests, Memory Decoder reduced perplexity, a measure of how confident the model is, by an average of 6.17 points across models like Qwen and Llama. That's a huge leap in accuracy for fields where precision matters. Think diagnosing diseases or analyzing financial trends. And here's the kicker. It works with any model that shares the same language, tokenizer, making it super versatile. So why does this matter? Memory Decoder solves the classic trade-off between adaptability and efficiency. It's like having a universal key that fits any lock. No need to rework the entire system. As AI continues to infiltrate specialized fields, this kind of innovation ensures models stay smart and swift. Let's break down why this works. Traditional methods like DAPT are like teaching a kid to read a textbook, memorizing words but not understanding context. Memory Decoder, though, teaches the model to mimic the patterns of answers in a database. It's not just about recalling facts, it's about knowing where to find them. This distribution alignment plus language modeling combo lets the model adapt like a pro. Here's the kicker. Memory Decoder doesn't just work alone. It teams up with in-context learning, a trick where models use examples in the input to adapt on the fly. Imagine a legal AI, even without prior examples, zero-shot, it outperforms the base model. Add 8 examples and it's supercharged. It's like having a tutor who not only knows the material, but also adjusts their teaching style based on your progress. But here's the twist. Memory Decoder creates super-focused probability distributions, like a spotlight on the most relevant words, not a floodlight. This precision reduces errors and boosts accuracy, making it ideal for high-stakes applications. So the next time you see an AI acing a niche topic, remember, it might be powered by a tiny, clever memory trick like this. Thanks for watching. Hit subscribe for more deep dives into the science behind the tech.